Alright, guys, I know that the Alimentary Canal Assignment was very difficult for a lot of people, and that you may still not understand it, even if we went over it in class. Or for others of you, you were not in class, you missed it for whatever reason that day, and you need an explanation. So here is your explanation. So this is the assignment as you saw it on Google Classroom, and I'm sure most of you looked at this and thought, what the? And then expletive deleted. But let's take this piece by piece, break it down, and see what we've got going on. So the first part of this that I recommend you do is I recommend you identify the regions. And these are those blue cards that you'll see on the side of this assignment. There are some clues here to kind of help you out. For example, I have marked on this part of the diagram, on this diagram, where the lips and teeth are. Hopefully they look slightly obvious. I know that this part of the diagram is not colored on your paper, but I hope that helps you realize, hey, if it's lips and teeth, we're probably looking at a mouth over here. Now, what you'll notice is that you don't actually have a blue card with the label mouth because I wanted you guys to have the more technical term. You all know what a mouth is, but I wanted you to recognize that there's another term for it. To figure this out, what I would highly recommend is you look up each of these 10 terms. That way it helps give you an idea of where in the digestive tract this is located. Some of them may be a little more obvious, like the stomach, but others you may have never heard of, like perhaps the cecum. And so you're going to need to look those up and get some background information. Another thing is I have identified what the contents of your alimentary canal are called when they are passing through various parts. So as you swallow food, it goes from your mouth down into your throat, and it's swallowed not as like a continuous stream of stuff just flowing down your esophagus. Instead, it's swallowed as a bolus, which is just kind of literally means ball. And it's a little ball of food or liquid or whatever that just travels down to your stomach as one unit. Then, once it reaches your stomach, it gets mixed with a lot of digestive juices, acid, enzymes, etc. And at that point, it's called chyme. And then chyme is also what it's called when it's in the small intestine. Now, after the small intestine, I am pretty sure that it is called feces in the large intestine throughout, but I'm not 100% sure whether it's called feces in the first two sections of the large intestine or not. For our purposes, we'll just call it feces. Now, once you've identified these 10 regions, it should make it easier for you to figure out what all of the other cards are and what goes in the few blanks that you have to fill out. I also want to point out that both the small intestine and the large intestine are divided into 3 parts, and I do not have any blue cards that are called small intestine or large intestine. Instead, I want you to learn the 3 parts of each of these. And I want to clarify something. In the large intestine, you're going to see a couple of different ways to divide it. And one way is going to be divided into the transverse, ascending, and descending colon. But this is not the distinction I'm looking for. That refers to kind of what the large intestine is doing in that area, and I will illustrate as follows. So let's say you have the mass that is your small intestine, and then you have a large intestine coming out of that. That large intestine is going to ascend, which is the ascending colon. It's going to travel across, which is your transverse colon, and then it's going to go down. When it goes down, it will go down to the area where you defecate from, and as it's going there, it's your descending colon. That's not the distinction that I want you guys to make. Why? Because we're looking for some more specific terms. Also, another distinction I want to make, when you have any tube-like structure in your body that has stuff flowing through it, the interior is called the lumen. So we will learn about the lumen of blood vessels. We can talk about the lumen of lymphatic vessels. We can talk about the lumen of some of the ducts in some of the accessory organs of the digestive tract, or we can talk about the digestive lumen. So that just makes it easier for some terminology. Now, the purple cards are what I would do next, and that is the junctions. The junctions are represented by a circle in the tract. So everywhere you basically have one of these dashed lines is representing a kind of junction between two regions. The, these are represented in the tract itself in the alimentary canal with these circles. And the appearance of the circle will tell you, is this a physical barrier or is this kind of more a functional barrier? For most of the functional barriers, there's nothing physically separating the parts of the alimentary canal. Instead, their differences might be microscopic or are more functional than anything else. If it's a closed circle, though, that means it's probably got a physical barrier there that it will physically prevent materials from traveling the wrong way. That keeps things one way. The physical barriers are usually either a sphincter, which is a ring of muscle, the most famous one being the anal sphincter at the end that you voluntarily control when you need to defecate, or a valve. Now, a valve can be found in other parts of the body. You may be familiar with valves in the heart, and they tend to look like this. So let's say that this is a valve. What happens is material can pass through one way, but it cannot pass the other way. It cannot get past that valve. So it's more of a way to prevent backflow. And you'll have a couple of places where you have those valves, at least one. So again, I recommend you look up each of the terms. So for example, if you look up the ileocecal valve, you should see a definition of it, which will tell you, oh, so that's what the ileocecal valve is. That's where it is. And if you know the names of the regions, you'll be able to more easily identify where it is. Notice that there are some of these junctions that are not labeled, and that's because we really don't have a name for them, because there really isn't a physical difference. The next thing that you'll see is actually a kind of very simplified graph of the pH at the different regions along the alimentary canal. And I know I don't have any axes on it on the paper, so I've expanded that chart or that graph and kind of added an axis on here so you can see. You can add things to your paper if you want. However, if there's really just not enough space to put a text box, you can always just refer back to this video. So the y-axis on this thing is pH. And the pH scale goes from 1 to 14. Anything from 1 and below 7 is an acid. Anything above 7 to 14 is going to be a base. And whether or not you are a strong or a weak acid or base depends on how close you are to 7. 7 is our special pH because it is neutral. So, if you're looking at this, anything that is close to 7, whether it's above or below, is going to be a weak acid or a weak base. Anything that is farther from the 7 is going to be strong. So a pH of 14 would be a strong base. Notice we don't really have any strongly basic areas in the alimentary canal. Not really happening. Then, if we look at the acid end, notice we do have a section that does have a fairly strong looking acid. And then hopefully you are aware of which area in the alimentary canal is most acidic. There is a very highly acidic part of your body, a particular organ that has a very low pH inside. So hopefully you can figure that out. Once you've identified the region, it will be fairly easy to see. And this graphical representation is pretty nice because it lets you see, aside from that sharp dip when you get to the very acidic part, for the most part, it's going to be either a weak acid or a weak base, not super strongly acidic or basic. It's going to hover pretty close to neutral. You do see like a spike as far as the pH goes here, and it becomes slightly basic. And the reason for that is because in the small intestine, you actually add a base called bicarbonate. And the point is you are wanting to neutralize the acid that you had in the previous organ. Alrighty. Next, what probably gave you the most mental fits, is processes. Um, there are 6 processes that occur throughout the digestive tract. However, not all of them occur in every single location. So, in some of these regions, you're going to have one, maybe two of these processes occurring. In other regions, you might have 3, 4 processes occurring at the same time. So, you've got ingestion, propulsion, mechanical and chemical digestion for our purposes tend to occur kind of in the same areas for the most part. So most of the time, you're going to have them together. Then there's absorption and defecation as well. So let's look at what each of these is. So these are the notes that I gave you guys in class when we were discussing this that tells you what the process is and where it takes place. So ingestion is eating or drinking something. In like this one case, you have some new information. It's talking about mechanisms of propulsion, including swallowing and peristalsis. So let's say that we have a tube as part of the alimentary canal that is going to be having some peristalsis happening. So food travels in like kind of chunks. We can assume we're looking at an esophagus with the bolus here, and it's going to travel in this direction. What happens is wherever the bolus or chunk of food is, your smooth muscles are going to squeeze down, and they're going to push that food to the next segment of intestine or esophagus or whatever. Once it gets to the next segment, that next segment is also going to squeeze, and it's going to keep pushing that food along in the right direction. All of this is involuntary, it's fairly complex, it's all under the control of smooth muscle and some involuntary parts of your nervous system. We did an activity in class last year where we basically took a pair of pantyhose or thigh highs, and what we did is we shoved a tennis ball in, and then we basically kind of squeezed to get it to go down to the bottom of the tube. Why were we doing that? That actually kind of mimics peristalsis. So if you've got pantyhose you can steal from somewhere in your house, not actual thieving, and ask permission, and you've got a tennis ball or a baseball, you can try and squeeze it down the tube, and you'll see kind of how peristalsis happens. Note, peristalsis happens throughout the entire tract, which is going to become relevant. That means every single box in the propulsion row or column needs to have a number 2 in it representing propulsion. So we learned about mechanical and chemical digestion in a previous set of notes, which will eventually go with a full set of digestive system notes on YouTube. We've got the locations where it takes place. Absorption is when you basically break these large complex molecules down into really small ones. Then those small molecules are going to be able to pass through the lining of the intestine to get to the blood. So let's say that we have the lining of our intestine, and I'm just going to draw a simple version on the other side. Let's say this is the lumen, and let's say that we have a nice blue nutrient of some sort. That actually cannot get in the spaces between cells because they're kind of like welded tightly together. This is going to be a simple epithelium with some really strong junctions in between. So what's going to happen is this nutrient is going to pass into the cell and then cross the cell to get out of the small intestine. Once it gets out of the small intestine, it is going to head into a system of blood vessels in the area. And then that's going to take that blood, carrying its nutrients, all the way down to the liver. So that's how absorption takes place. Note that nutrients are mostly absorbed in the small intestine. Water is mostly absorbed in the large intestine. So when you're chewing, you add saliva to your food. As material passes through your digestive tract, you may have some water added in there. Bile, for example, is a watery fluid. Pancreatic juice is a watery fluid. And so you're adding water into your intestines. Um, if you don't reabsorb the water in your large intestine, then you get that unpleasant sensation of diarrhea, which is watery feces, because you didn't take that water back. So, when you are sick and you have diarrhea, you'll be told by your doctor to consume lots of fluids to help replace that. If you don't replace that water that keeps getting, defecated out, then you run the risk of dehydration. There are, in fact, some diseases that kill uh, because they cause severe diarrhea, severe enough to cause people to dehydrate and then die from that. Luckily, with modern medicine, that's not so much of a concern. And then finally, there is defecation, releasing waste product, which is technically called feces. Yes, you can also refer to it as your poop, but if you want to sound smart when you're talking to other medical professionals, you're going to say feces. The process of releasing it is defecation. So if you are releasing feces, you are defecating. Where does it take place? As far as body regions or regions of the alimentary canal go, it's going to be the rectum. However, many of you guys correctly identified in class that it is the anus or the anal sphincter as well through which you defecate. So how does this look on on the actual diagram? Well, what you're going to do in the box, and in each of the boxes it basically says type, because I want you to type something there. You're going to put a number representing the processes that happen in that area. So remember, I said propulsion takes place everywhere, which means each of your boxes should have a 2 in it. Just like, and sorry, my sideways 2's got weird, just like the first box. Notice this first box for the mouth. We say ingestion is happening because you eat with your mouth. At least I hope you do. You eat with your esophagus. I'm worried about your anatomy. You have propulsion happen there because it happens everywhere. And then you also have mechanical and chemical digestion. In the mouth, the mechanical digestion is chewing, and the chemical digestion is through some enzymes released in your saliva, like amylase. So you may have some of these boxes with the exact same combination of processes because you've got the same processes happening. In other boxes, you may have, 1 or 2 processes happening. And ingestion and defecation can each only be found in one box because they each only happen in one region. Because think about it, one's an input of stuff, the other one is an output of stuff. And this is a one-way tube. Stuff only goes in one way and out the other way. No, we're not thinking about vomiting because that's when you're sick. And then finally, the last thing is to look at the chemicals that are involved in digestion. So there are 3 major regions where I wanted you guys to know about the chemicals involved. What I would do, once again, is look up these enzymes and other chemicals. So that way you'll see, oh, where are they released? That way you can try and figure out, okay, is it in this first region, the second region, or this third region? And that should hopefully be helped out by the fact that you have color-coded cards. So now that I've gone over all of that, I hope that makes this assignment easier for you guys, so that way you guys can go and get a nice, shiny, happy grade. Good luck, and go do your work.